Whether solar panels can be installed in basements depends on several factors. Firstly, basement conditions. Solar panels require proper ventilation to prevent overheating. Basements may have limited ventilation, which can lead to panel damage. Basements can be prone to moisture, which can corrode panels and affect their performance. The basement ceiling must be high enough to accommodate the panels and any necessary mounting systems. Secondly, electrical considerations. The electrical wiring from the panels to the inverter and grid connection must be accessible and properly routed. The inverter, which converts direct current power from the panels to alternating current power, should be installed in a dry, well-ventilated location, not typically found in basements. Thirdly, building codes and regulations. Some building codes and local regulations may prohibit the installation of solar panels in basements. Permits and inspections may be required, and compliance with safety standards is essential. Fourthly, practicality and aesthetics. Accessing and maintaining panels installed in a basement can be inconvenient and impractical. The aesthetic appeal of the basement may be affected by exposed panels. While it is possible to install solar panels in basements under certain conditions, it is generally not recommended as the ideal location. The challenges and limitations associated with basement installations often outweigh the benefits. It is advisable to consult with a qualified solar installer to determine the feasibility and suitability of basement installation for your specific situation. Installing solar panels in a basement presents several challenges that typically make it a less desirable option compared to rooftop or ground-mounted installations. Let's delve deeper into each of the factors previously mentioned, expanding on the specific concerns and considerations. Starting with basement conditions, ventilation is a critical factor for the efficient operation and longevity of solar panels. Solar panels generate heat as they convert sunlight into electricity, and proper ventilation is needed to dissipate this heat. Overheating can significantly reduce the panel's efficiency and lifespan. Basements, by their nature, often have limited airflow and poor ventilation. This is due to their underground location and the lack of windows or other openings for natural air circulation. Without adequate ventilation, the panels can overheat, leading to a decline in performance and potential damage. Installing ventilation systems, such as fans or vents, can help mitigate this issue, but this adds to the overall cost and complexity of the installation. Moisture is another significant concern in basements. Basements are often prone to dampness and humidity, especially if they are not properly sealed or waterproofed. Excessive moisture can lead to corrosion of the solar panels and their electrical components. Corrosion can degrade the panel's performance, reduce its lifespan, and potentially create safety hazards. Additionally, moisture can cause electrical shorts and other malfunctions. To address this issue, it is necessary to ensure that the basement is adequately waterproofed and dehumidified. This may involve installing a vapor barrier, sealing cracks in the walls and floor, and using a dehumidifier to maintain a low humidity level. These measures can add significant costs to the installation and require ongoing maintenance. Height and space are often limited in basements. Solar panels require sufficient space for installation and maintenance. The basement ceiling must be high enough to accommodate the panels and any necessary mounting systems. In many basements, the ceiling height is too low to comfortably install and maintain solar panels. This can make the installation process difficult and potentially create safety hazards for installers. Additionally, the available floor space in the basement may be limited, especially if the basement is used for storage or other purposes. This can further restrict the size and number of solar panels that can be installed. Moving on to electrical considerations, wiring is a crucial aspect of any solar panel installation. The electrical wiring from the panels to the inverter and grid connection must be accessible and properly routed. In basements, routing the wiring can be challenging due to the presence of walls, pipes, and other obstructions. The wiring must be installed in accordance with electrical codes and safety standards to prevent electrical hazards. It is essential to use appropriately sized and insulated wires to handle the current and voltage produced by the solar panels. Additionally, the wiring must be protected from physical damage and moisture. This may involve using conduit or other protective measures to safeguard the wiring. The inverter placement is another important consideration. The inverter converts direct current power from the panels to alternating current power, which can be used to power appliances and equipment. The inverter should be installed in a dry, well-ventilated location to prevent overheating and damage. Basements are often not ideal locations for inverters due to their high humidity levels and poor ventilation. Installing the inverter in a basement can increase the risk of electrical problems and reduce its lifespan. If the inverter must be installed in the basement, it is essential to ensure that the area is properly ventilated and dehumidified. Additionally, the inverter should be mounted on a wall or other surface to protect it from moisture and physical damage. Next, building codes and regulations play a significant role in determining the feasibility of installing solar panels in basements. Some building codes and local regulations may prohibit the installation of solar panels in basements. These regulations may be in place to address safety concerns such as fire hazards or electrical risks. It is essential to check with local authorities to determine whether basement solar panel installations are permitted and what specific requirements must be met. Permits and inspections may be required for basement solar panel installations. These permits ensure that the installation meets safety standards and building codes. The inspection process may involve verifying that the wiring is properly installed, that the panels are securely mounted, and that the inverter is located in a safe and suitable location. Compliance with safety standards is essential for any solar panel installation. This includes ensuring that the electrical system is properly grounded, that the panels are protected from overcurrent, and that the installation meets all applicable safety codes. Failure to comply with safety standards can create significant safety hazards, such as electrical shocks or fires. Concerning practicality and aesthetics, accessing and maintaining panels installed in a basement can be inconvenient and impractical. Solar panels require periodic maintenance to ensure that they are operating efficiently. This may involve cleaning the panels, inspecting the wiring, and checking the inverter. Accessing panels installed in a basement can be difficult, especially if the basement is cluttered or has limited headroom. This can make it more challenging to perform maintenance and repairs. The aesthetic appeal of the basement may be affected by exposed panels. Solar panels are not typically considered to be aesthetically pleasing, and their presence in a basement may detract from the overall appearance of the space. This can be a particular concern if the basement is used as a living area or for other purposes where aesthetics are important. While it is possible to conceal the panels behind walls or ceilings, this adds to the cost and complexity of the installation. In conclusion, while it is technically possible to install solar panels in basements under certain conditions, it is generally not recommended as the ideal location. The challenges and limitations associated with basement installations often outweigh the benefits. Factors such as limited ventilation, high humidity levels, restricted space, and built-in code restrictions can make basement installations difficult and costly. It is advisable to consult with a qualified solar installer to determine the feasibility and suitability of basement installation for a specific situation. A qualified installer can assess the basement conditions, evaluate the electrical requirements, and determine whether the installation is permitted by local regulations. They can also provide recommendations for addressing any challenges or limitations associated with the installation. Before making a decision about installing solar panels in a basement, it is essential to carefully weigh the pros and cons and consider all of the relevant factors. In most cases, rooftop or ground-mounted installations are a more practical and cost-effective option. Now let us discuss the specifics of solar panel technology itself. Solar panels, also known as photovoltaic panels, are devices that convert sunlight into electricity. They are made up of many individual solar cells, which are typically made from silicon, a semiconductor material. When sunlight strikes the solar cells, it excites electrons in the silicon, causing them to flow and create an electric current. This current is direct current or DC electricity. The direct current electricity produced by the solar panels must be converted to alternating current or AC electricity, which is the type of electricity used in homes and businesses. This conversion is done by an inverter, which is an electronic device that changes direct current to alternating current. The alternating current electricity from the inverter can then be used to power appliances, lighting, and other electrical devices. Any excess electricity can be fed back into the electric grid, earning credits or payments from the utility company depending on the net metering policies. Solar panels are typically installed on rooftops or on the ground, where they can receive maximum sunlight. The panels are mounted on racks or frames that are securely attached to the roof or ground. The wiring from the panels is connected to the inverter, which is usually located indoors. The installation process typically involves several steps, including site assessment, system design, permitting, installation, and inspection. It is essential to hire a qualified solar installer to ensure that the system is installed correctly and safely. The performance of solar panels is affected by several factors, including sunlight intensity, temperature, and shading. Sunlight intensity is the amount of sunlight that strikes the panels. The higher the sunlight intensity, the more electricity the panels will produce. Temperature affects the efficiency of solar panels. As the temperature increases, the efficiency of the panels decreases. Shading can significantly reduce the output of solar panels. Even partial shading can significantly reduce the amount of electricity produced. It is essential to minimize shading by selecting a location that is free from trees, buildings, or other obstructions. Solar panels require periodic maintenance to ensure that they are operating efficiently. This may involve cleaning the panels to remove dirt and debris, inspecting the wiring to check for damage, and checking the inverter to ensure that it is functioning properly. The lifespan of solar panels is typically 25 to 30 years. However, the actual lifespan may vary depending on the quality of the panels and the environmental conditions. Solar panels are a clean and renewable source of energy. They do not produce any air or water pollution, and they do not contribute to climate change. Solar energy can reduce reliance on fossil fuels, lowering energy costs and promoting energy independence. Solar panels are becoming increasingly affordable and accessible, making them an attractive option for homeowners and businesses. Government incentives such as tax credits and rebates can further reduce the cost of solar panel installations. The installation and maintenance of solar panels should always adhere to the National Electrical Code, or NEC. This code provides comprehensive standards for safe electrical practices. For example, NEC Section 690 covers solar photovoltaic systems, addressing wiring methods, overcurrent protection, grounding, and disconnecting means. Specific NEC tables, such as Table 310.16, provide ampacity ratings for conductors, which are essential for determining the correct wire size for solar panel circuits. For instance, if a solar panel system has a maximum current of 15 amps, the wiring must be sized to handle at least 125% of that current, resulting in a minimum ampacity of 18.75 amps. Consulting NEC guidelines and working with qualified electricians are vital to ensure safe and code-compliant solar installations.